Alright, we are going to solve the question above. Question says if the beam cross section is rectangular having a width of 75 mm, determine the required depth such that the maximum bending stress induced in the beam does not exceed 40 meganewton per meter square. And of course, this is our rectangular beam, and from this point to this point is the diagonal, which is represented by D, and from this point to this point is depth, and from this point to this point is 75 mm. So these are the given datas. Alright, so for us to solve this question, you are going to recall carefully that the moment of inertia of a rectangle is given to us as what? BD cubed over 12. And the y mass, that is the distance from the bottom to the neutral axis, is given to us as depth divided by 2. Alright. So again, you are going to recall from Fleischer equation that says we have m all over I is going to be equals to what? It's going to be equals to our maximum stress all over what? Y max. So from here, if we make our maximum stress the subject, so this will be equals to m multiplied by y max all over what? I. Alright. So we can substitute now. So we are going to have our maximum stress, which will be equals to m multiplied by our y mass, which is d all over 2, divided by what? Divided by bd cubed all over what? 12. Alright. So now this will be equals to m, which is our maximum bending moment, multiplied by d all over 2 all over. Now I can decide to factor out d all over 2 from here. I bring out d all over 2 from here, I'll be left with bd square all over 6 here. So d all over 2 will go with d all over 2. Then our maximum stress will be equals to m all over what? bd square all over 6. So if I cross multiply, it means that my m will be equals to maximum stress multiply by bd squared all over 6. So this is the formula that we are going to use to calculate what the required what we are asked to find in this question. Alright, so now let's keep that aside. Again, we are going to be using Pythagoras theorem for this rectangular beam. We know that from this point to this point is our diagonal, and this point is this length here is depth. It means this place too will also be depth, and here is our base. So it means that if we apply Pythagoras theorem, it says our depth, our diagonal part squared is equals to, because we know that this is our 90 degrees, our hypotenuse side. The hypotenuse side is equals to the sum of the two other sides, provided that they are all what? Squared. So b squared plus what? Plus d squared, right? So if we make d squared the subject, so d squared will be equals to d squared minus b squared. Alright, so if we multiply through by b, I'm going to have this to be what? bd squared will be equals to bd squared minus b cubed. Alright, so for the condition of maximum stress, the product of bd squared is going to be maximum by taking the first derivative of this product in respect to what? In respect to b. In respect to b, and equating it to be equals to what? 0. Alright, so it shows that here we are going to have d all over db into bd squared will be equals to del all over then in respect to b into bd squared minus b cubed. All right. So if we differentiate, so what we mean is for the condition of maximum stress, the product of bd squared will be maximum by differentiating this product in respect to what b and equating it to 0. So now we are going to equate what we have here to be equals to 0. So it shows that 0 will be equals to because the reason why I'm emphasizing on this is you are not differentiating what we have here. You are not differentiating this. Please take note of that. What we are just saying here is that for the condition of maximum strength rather, that the product of bd squared will be maximum by first differentiating the product in respect to b and equating it to what? 0. All right. So now this is what we are going to differentiate here. So if we differentiate this, it means our d squared here will be the what? It's going to be our constant. If we differentiate b in respect to b, that is 1. So here 1 multiplied by this, we are going to have d squared. So we are going to have d squared minus, if we differentiate b to the power of 3, we are going to have 3b squared. All right. So it means if we bring this to this other side, we are going to have 3b squared to be equals to what? D squared. And don't forget, we know that our d squared is equals to what? B squared plus what? D squared. So we are going to substitute that here. We are going to have 3b squared to be equals to what? Is equals to b squared plus d squared. So if we collect the like terms, I'm going to have 3b squared minus b squared to be equals to what? D squared. So 3b squared minus b squared, I'm going to have 2b squared will be equals to what? D squared. All right. So that is what we are going to have. All right. So if we want to make d the subject here, so we can also say d squared is equals to what? 2b squared. So if we make d the subject, I'm going to square both sides. So now it means that our d now will be equals to root 2 then b. So that is what we are going to have for our d. And don't forget that our base here, our base is 0.075, and root 2, if you press root 2 in your calculator, you are going to have, okay, that is the product of root 2 multiplied by 0.075. So if you press this in your calculator directly, that is root 2 multiplied by 0.05, you are going to have 0.106. So you are going to have 0.106 meter. So that is what you are going to have. And if you multiply by 1000, you are going to have your depth to be equals to 106 mm. All right. So now that we know our depth, we can therefore come back to this formula now and substitute. So we can calculate our maximum bending stress. All right. So now we're going to have M, which is our maximum bending moment. Our maximum bending moment is going to be equals to, here we have our maximum bending stress to be what? Is equals to what? 40. So it's going to be 40 multiplied by what? Our base. Our base is given to us as 0.075, then multiplied by our depth, which is we are using meter, so this is going to be 0.106 squared, then divided by what? Divided by 6. So if you press this directly in your calculator, our maximum bending moment will be equals to 0.00518. So of course, what will be the unit for our bending moment here? Don't forget, this unit is in mega. So it's going to be what? It's going to be mega Newton meter. So this will be the solution to the above question. If today is your first time of coming across our content, don't forget to join our membership program. If you join, you are going to have access to more premium video that addresses more engineering concepts. And don't forget to click on the subscribe button, and don't forget to click on the notification bell so as to get notified whenever we upload premium content like this. Thanks. Stay tuned. Don't forget to share with your friends who might be in need of it. Thanks.